single cavity mold right now we are designing, right? See, okay, now or here. So understood about these things?
Yes, sir.
Okay, so apart from this, we have to take the calculation. For example, first of all, we have to clamp this plate, top plate with the cavity plate, right? And we have to clamp the we 1 minute. We have to clamp the cavity plate with this insert, right? But with the help of bolting, with the help of bolting. And apart from the bolting, for the best alignment, or the better alignment, what we have to use? What we have to use? Dowels, right?
Correct.
Dowels. The dowels also used into the mold. Right now, I'm not used dowel in this mold, but I have to clamp this two plate cavity and the top plate with the bolt, right? With the bolt. And again, I have to clamp this plate together with the bolting, right? Okay. But for the bolting, we have to understand the calculation or the selection procedure. Okay. For the bolting, there is a two things. One is the selection and second one is the calculation. Is it clear? That okay. Okay. Which type of bolt we have to use for the clamping in mold?
Allen screws.
Allen bolts, right? Allen bolts. Okay. Of M series. Of M series, right? Okay. In order to select, we have to see this bolt selection and the calculation PPT, right? Okay. So you understood about these things. Okay. To see what is the procedure for bolt selection or the calculation. Is it clear? See here. 1 minute. See here. So step by step, I will guide you about that. Okay. So how to select the M series Allen bolt. Okay. So first step is that identify the load requirement. So what is the load requirement? First of all, tell me. Into the mold. For example, if you have mold, so what is load exert on the mold? First is the clamping force.
Correct.
Right. Second is the injection pressure. Okay. So against the injection pressure, we have to apply the clamping force. So this is the maximum force which has been applied on the mold, right? Which is applying on the mold in every time, right or wrong? Okay. And once you calculate this clamping force, so you have to add few factor of safety also. Okay. So factor of safety you can take around 10% to 15%. Is it clear? Generally we will take the 10% factor of safety, which is enough, right? Which is enough. Is it clear? Okay.
Yes.
Second step is that determine the number of bolts. For example, you have a mold like this. है ना? Yes. Okay. For example, you have a mold like this. Okay. See. 1 minute. You have a mold. So basically, you have a mold like this. Okay. So for example, for this mold, depending upon the size, length or the width or the you can say that weight of the mold, right? Depending upon that, you are selecting the M12 bolting, right? And you are selecting the M12 bolting and you are taking the 4 bolt. Is it clear? So here you can see that this is the position of 4 bolt, right or wrong? Right? But if I am telling you for example, if I have M10 bolt and instead of the M12 bolting or the number of 4, I can use 8 bolt, right or wrong, of M10. It will be clamped in a better way, right or wrong?
Yes.
So you can say that for the 4 bolt of the M12 or the 8 bolt of the M10 has the same effect.
More than 12 mm it will be.
But you can take that it has a similar effect, or there will be no issue, right or wrong, into the mold or the operating, right? Understood or not?
Yes, sir. Understood.
Understood. So you can see that. So I'm telling you about that the M12 or the M10 or whatever bolt you are using, so basically it is depending upon the material of that bolt also, right? material of that bolt also. Okay, so for example, I am selecting the 4 bolt. Generally we will take the 4 bolt. Is it clear? For the small mold, the 300 or the 400 by 400 mold, we are choosing the 4 bolt, right, which is the number of bolt. So basically it is depending upon the how much dimension we are taking for our mold, right. So measure the dimension and select the number of bolts how much you are using, and depending upon the placement, so decide the number of bolt and the placement of the bolt where you want to place. For example, your guide pillar will be here, so here from the bolt, from the guide pillar, you have to take some distance and you have to take the placement, right or wrong, for the bolting. And it will be uniform for all over the side, right. From this point it is about 20 mm, so you have to take the 20 mm from this point also, and here will be the 20 mm here. So you can see that this is the uniform, right or wrong.
Yes.
Understood? So first thing is that identify the load requirement, which is nothing but clamping force and the injection pressure, and you have to add the safety factor of safety into the clamping force. Second one is determine the number of bolt, how much bolt you need, right. For example, you need only 4 bolt. So depending upon that 4 bolt, we have to choose the appropriate bolt, right. Third one is that calculate the clamping force per bolt. For example, if you are selecting the 4 bolt for the mold, number of bolt is 4 for example, so we have to calculate the how much clamping force required per bolt, right or wrong. So in third step, you can see that we have calculated the total clamping force, and that total clamping force will we have to divide by the number of bolts. Okay, so you will get the force per bolt. Is it clear?
Yes.
I hope you understood about this, right?
Yes.
Okay, see here, step 1 here. So first of all, calculate the total clamping force, or how you will calculate the clamping force, depending upon the projected area or the cavity area and the injection pressure, right. In the injection pressure, so what you will get the total clamping force, right, total clamping force. So you can see that F equal to P multiplied by A. This is the simple formula as I told you, right. Okay,
Yes.
step 2, determine the number of bolts. Okay, how much number of bolts, which is the n, so which is depending upon you. For example, if you want 8 number of bolts, so you can select 8 number of bolts, or if you need 4 number of bolts, you can select the 4 number of bolts. It is depend upon you, right. Third step is calculating the force per bolt. Okay, so you have calculated the clamping force and you have decided the number of bolts. So nothing but force per bolt will be it is the FB, force divided by number of bolts. So what you will get? Force per bolt on a single bolt, right? Is it clear? See here. Okay, so this is our calculation. Now come on the selection. Okay, what is the step 4? Select the bolt size based on the tensile strength. Okay, now if I am talking about the tensile strength, so basically it is nothing but I am talking about the material. Okay, but basically in market there is the availability of the bolting about grade 8.8, about grade 10.9, about grade 12.9. Okay, so what is this number? It is showing the strength of the bolt. What is showing? It is showing the strength of the bolt, right? For example, if you are taking the 8.8 grade bolt of M12, so basically this grade or this M12 bolt will be, or again if I am taking the same bolt, M12 bolt of 12.99 grade. So what is the difference between both? The tensile strength of this grade will be higher than this. Is it clear? So basically 12.9 grade will be has a good strength, right? Has a good strength. That's understood or not?
Yes, sir.
Okay. For example, if this grade has a low, you can say that for the low purpose, this is the medium or this is the high, or depending upon the costing also, right? So it's a 12.9 grade has a higher cost also, right? higher cost depending upon the materials I told you. So you can see that tensile strength of this bolt 8.8 grade is around 800 megapascal. Okay, here you can see that tensile strength for the 12.9 grade is around 1220 megapascal or 1200, you can say that. Is it clear?
Yes.
Okay, so now here you can see that this is nothing but step 4. Okay, so bolt material typically M series Allen bolt are made of high strength steel, right? For example, 12.9 bolt have a tensile strength about 1200 megapascal. Okay, so if I will take the cross section area of that M12 bolt, so it is nothing but it is about AB or any type of bolt. For example, I am taking the M12 or the M10. The cross section area will be in mm square. Okay, so here you can see that by this formula you can see that this is the LB. So what I am finding here right now, AB multiplied by tensile strength and multiplied by factor of safety also. Okay, so what I am finding here, what I am calculating here, nothing but LB is the allowable load per bolt. That how much load you can apply on a per bolt. Is it clear?
Yes.
Okay, so for step 4 you have to refer a table. Okay, you have to refer a table. Is it clear?
Yes.
Okay, understood? So step 5 is nothing but you have to verify the bolt size. So in previous point 5.1 or point 2, what we have calculated? FB, which is the force per bolt. So your force per bolt should be less than or equal to of LB, which is the allowable load, right? If this condition is verified, you can say that, right? If this condition will satisfy, so you can select that bolt which you have selected, right? Understood or not?
Yes, sir.
Not quite understood, right? Right. Let's take the example. See, this is nothing but what is this? Tell me. See, this is the M3, M4, M5, M6, M8. What is this? This is the bolt, right? Bolt size of M series. Okay. Here you can see the tensile stress area. What is the meaning of tensile stress area means? For example, you have a bolt like this, right? Or this is nothing but this is the cross section area. This is the cross section area, right? Right? So here you can see that for the M10 or M12, see here what is the cross section area for this? 84.3 mm square. See, 84.3 mm square. Is it clear? Cross section area. So what I am doing here right now, tell me, tensile strength multiplied by tensile area. So basically what you will get? Allowable load. Okay, so here you can see that for the grade 8.8, here 67.44 kilonewton, which is the allowable load on per bolt. You can see that, right? And if I am talking about the 10.9, it is about 87.67 per bolt, right? You can apply this load if you have a 10.9 grade M12 bolting. This is the maximum allowable load. Here you can see that 102.85, okay, which is the allowable load on 12.9 grade M12 bolting. Right? See here, for example, see the example calculation of tensile strength for a specific bolt. Like for example, I am taking the M12 bolt, right? Here you can see that this is the first tensile strength and this is the tensile stress area. In previous slide you can see that, right? Same here. See, this is the table for your reference, right? See, this is the tensile area, right? Multiply by 1200. What you will get? You will get this value, right?
Yes.
Okay. So see here. F tensile strength AS, which is the tensile area. So 20 megapascal and 84.3 mm square. So what you will get? You will get 102.85 kilonewton, right? Kilonewton. Is it clear? So this calculation confirm that the M12 bolt of grade 12.9 can withstand a maximum tensile load of appropriate 102.85 kilonewton before failure. Right? Again, here, for example, for our mold, this is the given data. Okay, this is the given data that the clamping injection pressure required for fill the component it is 80 megapascal and the projected area is 2000 mm square and the number of bolt is the 4 and here you can see that tensile strength of bolt 12.9 gauge which is about 1200 megapascal. Factor of safety I am taking 1.5 है ना 1.5 I am taking the factor of safety. So step 1 calculating the total clamping force, which is the first step of the injection mold design, right. See, force equal to pressure multiplied by area, so you will get what you will get FB.
Force per bolt.
So FB divided by number of bolt, right? Sorry, F in total force number divided by number of force. So you will get 40 kilonewton. 40 kilonewton. Is it clear? Okay. Again, the cross section of M12. Allowable load will be this.
Okay.
102, but you are taking the factor of safety also, that's why the factor of safety for the allowable load, that's why I am dividing the by 1.5, right? So basically by adding the factor of safety you will get 67 kilonewton. 67 kilonewton. Here see the difference. So here this is the verification that 40 kilonewton is less than or equal to 67 kilonewton. 67 kilonewton. I am taking the factor of safety again, right? Remember one thing, I am taking factor of safety over. Okay, so here you can see that 40 kilonewton is less than 67. So basically you can see that M12 bolting is we can use for our mold, right?
Yes.
Okay, understood or not? But this condition should be satisfied. So we can use M12 bolting or the M12 bolting or M14 bolting or the M16 bolting, M20 bolting, right? But this condition should be satisfied. Understood? Has understood or not?
Yes, sir.
Okay. So here for clamping this, I am taking the right now M10 bolting, right? Because this is the small mold for, right? 1 minute. Okay. Achha, here I am not designing right now guide pillar and the guide bush, right? Okay, why I am not designing right now? Because for that, why? Tell me.
Still, we not clamp the dies and.
Because for that we have to learn the calculation. That's why right now I am not taking that thing, right? So here from this point to this point I am taking the 50 mm, this is 50 mm, right? Okay, and here this is the center. So I am taking this point again, this point and this point and this point will be mirror here. Okay, see, right? Okay, Control Z. See, right? This is the 4 point, right? So at this 4 point, I will take the bolting. See, Allen bolting, right? Which will be the counter bore. See, this is the Allen bolting. So from this point to this one, I will take the end length. It is the solar depth right now, 16 depth. So I can take the 25, right? And click OK. See, this is the bolting right now. Here, same bolting I will take here at the same point, right? What is the day today? Oh no, day. Thursday, right? So today will be the Friday, right? Last class of this week. So today I will check your design work, okay? Sorry, tomorrow I will check, right? Not today. Tomorrow I will check. See. Okay. So this is nothing but I have used a bolting right now. Okay, understood or not?
Yes.
Okay, this is the single cavity mold. Single cavity mold with the core and cavity inside. With the you can say that we have prepared the open tolerance component. Open tolerance component, right? Okay, here this is the mold. 1 minute, and or this is the way. From this side, this is the top view, right? And from this side, your mold will be lifted by the crane, and your mold will be into the injection molding machine, right? Okay, so where will be the eye bolt here? At this point, right?
Yes.
Y bolt will be into the mid of the plate. Here, it will be like this. 1 minute. It will be like this, like this, like this. Right. 1 minute. Okay, I am taking the eye bolt 10.20. Okay, 10.20. 10.20. Why 10.20? Tell me.
M12.
Why? Sorry.
M12 screw.
M12. But what is the 10.20 here?
Drill diameter.
Drill diameter, right? So you should have knowledge about the drill diameter also. Achha, what is the drill diameter for the M8?
6.5.
6.8, 6.75, right? Basically, accurate diameter is the 6.75, but we can take 6.8 mm, right?
Okay.
Okay, so here I am taking the 22. 1 minute, 22 mm I can take, and it will be like this. Okay, here I am taking the chamfer. Okay. Okay, so this is the hole for the eye bolting, right? So you can prepare the single cavity mold, right? Easy one. Any software you can use for designing the mold, right? There is no issue of software. But if your concept is clear, then you can design the mold, right? You can design the mold. Understood? Okay, one more thing I will create here, which is the acha, what is the purpose of this? Tell me.
The radius.
Now this.
Chamfer.
Why? But why I am giving the chamfer here like
Should
this?
not cut the one's hand.
This is the reference cut.
Oh, okay.
Okay, what is the why reference? During the assembly of these plates, right? This reference cut will help to the assembly, right? In the tooling, you can see that, right? So we can place, yes, easily we can identify where we have to put the plate, and from right. So one by one you can select that, right?
Okay.
So this is reference cut is very important, right? So right now we have completed the single cavity mold, but in this mold you can see that we have not designed yet a few components like guide pillar, guide bush, and here you can see that this is the guide pillar, guide bush for ejector grid, right? And the return pin I have not designed yet, right? But in multi cavity mold we will design complete that thing, right? And one more thing we have not designed here, which is about cooling lines or the cooling pipes, right?
Correct. Yes.
And that thing we will cover in multi cavity mold. Why? Because for that we need to understand the calculations, right? We need to understand the calculation. So as I told you, we have covered the calculation for the bolting and the selection for the bolting. So that's why I have prepared the bolting here, right?
Okay.
Okay, so that's why calculation is very important. Without calculation there is no design. Is it clear? So we have to understand first of all calculation of that. Is it clear?
Okay.
Okay. See you in next lecture, which will be on tomorrow. So I will see the minimum core and cavity. Okay. Acha, you have a duster component. Tell me.
Which one?
You have duster component, duster part.
No, sir.
No, so I am just sending the duster component. Okay, you just have to prepare the core and cavity of that, or core or cavity of that, right?